There are easy technologies that might impact every one of us, just like electricity did more than a century ago. As of May 2025, one of the leading companies in that field reported over 800 million active users in a single month. Just a year earlier, that number was 180 million, and during the very first week after launch, they already reached 1 million users. These numbers reflect only one company, OpenAI, with its product, ChatGPT. OpenAI is not the only one, so the total number of users are actually much higher. Today, we'll discuss not exactly ChatGPT, but breakthrough technology on which it is based. What is it? I'm talking about large language models, often referred to as LLMs. Chances are you already use them in your everyday life, even if you are not aware of it. But what are they exactly? Why have they spread so quickly, and where might this all be going? To answer that, let's go back to the beginning. To really understand how modern language models and AI assistants actually work, we need to go back to the basics. Back to something called neural networks. They're one of the most powerful tools in machine learning, and surprisingly, they're also kind of intuitive. It all started in 1950. Alan Turing, the same Turing behind Turing machine, came up with a simple but revolutionary idea, a way to test whether a machine could think like a human. It became known as the Turing Test. Imagine this. You are having a conversation, just text, with two people, one of them human, the other a machine, but you don't know who is who. If you can't tell them apart, then a machine is set half as a test. It was the first serious attempt to ask the question, can we actually build artificial intelligence? Fast forward to 1958. Psychologist Frank Rosenblatt introduces something called the receptron, the very first artificial neural network that could actually learn. It could recognize super simple patterns, like shapes and outlines, and it could learn from its mistakes. If it got something wrong, it could adjust its internal settings. So the next time it would get a little closer to the right answer. That idea, learning by adjusting, became the core principle behind all modern neural networks. So, what is neural network anyway? Imagine a huge web of artificial neurons, all connected, all passing signals back and forth. They are inspired by how we think human brain works. Not exactly the same, of course, but similar in spirit. Let's say you show this network thousands of photos of cats. Over time, it starts to pick up on key features. Pointy ears, round eyes, the general shapes of the body, even if no one told it what a cat is. Each neuron looks at a small piece of the picture, maybe just the brightness of one pixel, and decides whether to pass that signal forward or not. It straightens and weakens the signal depending on what patterns it has learned so far. And when the network makes a mistake, it gets punished. It updates the internal settings just a little to make that same mistake less likely next time. And here is the key. The more layers and connections you add, the deeper the network can go. By the way, that's why it's called deep learning. It can analyze patterns, extract meanings, even understand, in a way that feels almost human. Now, neural networks didn't take over the world right away. In fact, they went through a lot of ups and downs. Back in the 1960s and 70s, people were excited. But computers were slow, data was limited, and progress stalled. This led to what's now called the AI winter, a time when funding dried up and people stopped believing in the tech. That changed in 2012, thanks to a breakthrough called AlexNet. Geoffrey Hinton and his team had been working on neural network for years, even when most researchers had given up. But then they entered the big competition called ImageNet, where the goal was to classify millions of images, and AlexNet just blew everyone away. Its error rate was half of anything that came before it. So what made it so special? First, it was deeper, more layers, more power. Second, it used GPUs, not regular processors, which made training way faster. And third, it brought in new training tricks like better activation functions and regularizations, which made it smarter, more accurate. That was the moment everything changed. People realized neural networks weren't just some academic toy. They could compete with humans, in some areas even beat us. And that, right there, was the beginning of new era in artificial intelligence. The era we are living in right now. After the success of AlexNet, neural networks started spreading fast. They were everywhere, but as impressive as they were, early models had a serious problem. They struggled with long sentences. See, for a computer, text is just a sequence of numbers called tokens. A token can be a word, a part of word, or even just a single character. Now, here's the issue. Those older models try to squeeze the meaning of an entire sentence, sometimes even a full paragraph, into just one fixed length vector. Imagine you've just read a whole novel, but at the end, you are only allowed to remember 10 words. Of course, you would lose most of the meaning, especially if the most important word were far apart from each other. And that's a real problem, because language is full of things like pronouns, references, long sentences, subclauses, and machines need to track all of that. Back then, we had models called recurrent neural networks, or RNNs. They read text one word at a time, like humans do, but their memory was short. By the time they got the end of the sentence, they often forgot what was at the beginning. So yeah, not great for translation for anything long and complex. But then came 2014. A researcher Dmitry Bandau and his team had an idea. What if, instead of compressing the whole sentence, we let the model focus only on the words that matters most? This became known as the attention mechanism. It worked kind of like how we read. When something's confusing, we go back and reread that one part again, right? That's attention. And suddenly, translation models started getting way better. But they were still slow, because they worked step by step, one word at a time. Then, in 2017, everything changed. A team of Google Brain published a bold paper with memorable title, "Attention is all you need." And they meant it, because they designed a model where attention wasn't just a helper, it was the entire architecture. They called it the transformer. And unlike previous models, the transformer didn't read one word at a time. It looked at the entire sentence at once. This changed everything. It captured full context, trained way faster, and handled huge datasets with ease. It could dynamically figure out how important each word was, depending on everything else in the sentence. Like in the sentence, "She planted the tree because it was beautiful." The model knew that it means the tree, not the act of planting. And that's huge. The transformer was more accurate, it trained faster, and most importantly, it scaled. The bigger the model, the better it performed. This became the foundation for large language models like GPT, Bird, Claude, Gemini, Llama, and many more. But it didn't stop at text. Soon, the same architecture was being used for image generation, like Midjourney, speech synthesis, video generation, even biology, like predicting protein structures, and robotics, self-driving, and more. In a way, the transformer became the internal combustion engine of the digital age, a general-purpose engine powering the most advanced AI systems in the world. But all that power comes at a cost. Training these massive models requires thousands of GPUs, huge amount of energy, and budgets in the hundreds of millions of dollars. The transformer isn't just an algorithm anymore. It's infrastructure. It's shaping our economy, our culture, and even our society. And just like that, a new chapter began in the story of artificial intelligence. After the paper Attention is All You Need was published, something big happened. The transformer architecture sparked a new era in artificial intelligence, the rise of large language models. The core idea behind LLMs was actually pretty simple: train a transformer on massive amounts of text, books, articles, conversations, even code, and teach it to do just one thing: predict the next word. That might sound almost trivial, but this ability, it changed everything. Because to predict the next word well, the model has to understand a lot. It needs to grasp context, grammar, writing style, and even the hidden intent behind what the author is trying to say. The first major model to do this was GPT, Generative Pre-trained Transformer, developed by OpenAI. Its creators, Ilya Sutskever, John Schulman, and Wojciech Zaremba, noticed something important. The more data you give it, and the bigger the model gets, the smarter it becomes. Already by 2019, GPT could write coherent, relevant text. Then came GPT-3 in 2020 with 175 billion parameters, and it stunned the AI world. It could hold conversations, explain complex topics, write code, and even compose poetry. For the first time, people started asking, are we seeing the first signs of artificial general intelligence? Later models like GPT-4 and others took things even further. They could work not just with text, but also with images, spreadsheets, code. They could reason, analyze, reflect, and this triggered a full-on AI boom. Microsoft invested over 13 billion into OpenAI and embedded LLMs into Word, Excel, even Bing. Google built its own models, Bird, Palm, and Gemini. Anthropic released Claude, focusing on safety and transparency. Meta launched open-source models like Llama, and xAI, Elon Musk company, rolled out Grok, baked right into the social network X. But these models, they weren't just chatbots anymore. They became the brains behind intelligent systems, capable of understanding natural language instructions, planning actions on their own, using tools like browsers, calculators, databases, and doing complex tasks, from idea generation to data analysis. What began as just predicting the next word suddenly became the foundation of a whole new kind of machine intelligence. A kind of universal interface between humans and information. But it didn't stop there. Transformers moved beyond text, because almost anything can be represented as a sequence. An image, a sequence of pixels. A video, a sequence of frames. Sound, a sequence of waveforms. Even medical data is a sequence, a timeline of symptoms, test results, and treatments. In medicine, LLMs can help doctors spot patterns or suggest the next step in patient care. In biology, models like AlphaFold can predict how proteins fold by treating their structure as a sequence of amino acids. And behind all this power, still the same idea: predict the next element based on context. That's it. That's the core principle. Thanks to this and large-scale training, transformers can now analyze and generate almost any form of information. They've evolved into universal tools, the building blocks of today's most advanced intelligent systems. And even more importantly, the foundation for decision-making systems of the future. Let's take a step further. We've talked about neural networks, transformers, and large language models. But now, something new is happening. We're entering the era of agents, AI that can actually act on its own. A neural network at its core is still a black box. You ask it a question, it gives you an answer, but most of the time you have no idea how it got there. And there is another problem. Every new prompt is actually isolated. The model doesn't remember what you was said before. No history, no context. Imagine talking to someone who forgets everything you just said after every single reply. They might sound smart, sure, but they can't follow a conversation. Not ideal, right? Especially when you are dealing with more complex tasks. So, what did developers do? Something simple but powerful. They started saving the conversation history and pasting it back into the model. It's like holding someone a quick summary of your last discussion, so they don't lose track of the topic. And from there, the next step was obvious. If a model can predict the next word, why not teach it to predict the next action? Think about it. In real life, we're constantly making decisions. What I should do next? What's the best tool for this task? How do I reach that goal? And that's how AI agents were born. These are systems that don't just respond to questions. They actually plan and execute tasks on their own. Give the model a set of tools, a browser, a spreadsheet, a calendar, an email app, and it will choose which tools to use, in what order, and for what purpose. Let's say you run a small cafe. Each day you check your social media messages, respond to customers' review, update the menu, manage your grocery list, and make sure everything's running smoothly. Now imagine this. An AI agent handles all of that. It reads your messages, figures out who needs a reply, who needs an apology, and who just left a nice comment. It seems which ingredients are running low, creates a shopping list, updates your menu, posts seasonal specials, even writes a caption with a photo, automatically. And while the agent handles the routine, you get the focus on what matters. Your coffee's vibe, your food, your ideas. This is already becoming real. AI agents are helping small business owners, freelancers, content creators, administrators, people who wear a dozen hats every day. Where it once took a full-time human, now an agent can step in, as long as it has the right tools and clear goals. This isn't just another chatbot, it's something more, a new kind of digital coworker. An assistant that can make decisions and get things done by itself. So we started with a simple idea, just predict the next word. But that simple idea, it turned into something much bigger. It evolved into technologies that are already transforming our lives radically and in real time. From early neural networks to transformers, to large language models, and now to intelligent agents. Artificial intelligence has become a powerful tool, able to create, analyze, and even act on our behalf. We are living in an incredible time. We are witnessing the birth of a new era, where humans and machines collaborate. An era where technologies helps us free up time for creativity, for critical decisions, and for the things that actually matter, real, meaningful communication. If you found this interesting, don't forget to like this video and subscribe to the channel. There is a lot more to come, more stories about the technologies that are already changing our world. See you in the next one.